One of the first functions we looked at in this course was f of x equals sine x over x. And what we looked at is that it had a limit as x approached 0, and that limit was 1, even though f of 0 was not defined. So right away I know there's a discontinuity right there, though I will say this is a continuous function. 0 is not in the domain and is continuous everywhere else. All right. But we're asked to find a continuous extension for the function. Well, what that means is, instead of just being continuous over its own domain, now we want it to be continuous literally everywhere. So now this discontinuity is kind of getting in my way. And so I'm asked to find a new function, big F, that's a continuous extension. So big F is supposed to look just like this, except for not have that discontinuity there. So I'm going to write down a formula for big F. When f is not 0, it should just be sine x over x. It should match everywhere else. And at x equals 0, we should get out 1. And the reason for that is because we have previously learned that the limit as x approaches 0 of sine x over x is 1. We took a limit. And hey, the function value has to match the limit to be continuous. And what that does now is it patches that hole. And now I have my nice, happy, continuous extension.